The title of this video is Reading an Abstract. Abstracts are not ordinary pieces of text, is the message here. They're not all the same, but they have something special about them that hopefully you'll get a sense of during this presentation. An abstract puts the best foot forward for the paper. The title does as well, but the abstract really gives you a sense of the value contained in that paper. Again, it's a first impression. If you write a bad abstract for any type of thesis at university, you'll fail. A bad title might get you a D, but a bad abstract will definitely get you a fail because the abstract represents the entire content. It is the summary, it is the essence of what is in the paper. Bad abstract, terrible paper. Like I said, a bad title will give you a D, but a bad abstract will get you a fail. This is something we all want to avoid. So let's talk about the relationship between engineers and executives again. I've already mentioned that there's several questions that engineers care more about than executives. And I mentioned previously that the title gives you a bit of the how and a bit of the what. So there's some common ground, but abstracts also give you some information that you can use and engineers can use when they're communicating with executives. Not all of the important information, but certainly some valuable information. So it really pays to understand what's in your abstract, but also what else executives need to know. So let's get into reading abstracts. As I've said before, there are several questions at several levels of detail. So what? What is the problem? What did you do to solve it? How well did it work? And what else does this work add? Now, engineers are interested in some of those bits, but executives are also interested in some of those bits as well. Let's have a look in terms of the core questions. An abstract gives the engineers the how and the why and the which technique they used, but there's no timing in that information. An executive will be more interested in the who cares, the what, some of the so what, but also the now what. What advantage does it create for their organization? They're looking at it from a business perspective and a different perspective from an engineer because they're looking into the sustainability of the business. It's a different perspective. As I said, the reason you need to take this perspective into account and the reason why I'm talking about this first is because in this course, I'm going to focus your attention on the questions that engineers ask. This is not an executive course. I'm focusing on these first because I need you to understand the contrast. What you're going to learn in this course is how to read an abstract, how to understand an academic engineering paper, and it is not going to help you in a conversation with an executive. It'll help you in a conversation with an engineer and an academic engineer, but not with an executive. So I need to give you this additional information up front to highlight that there are differences and you need to keep them in mind. So let's get into some of that detail. The text provided in an abstract can be decomposed into questions at a level of detail. Let's look at some examples that various people have constructed. This is an example of a meta-abstract, an abstract about an abstract. The first sentence of an abstract should clearly do something. The second sentence should do something. The last sentence should do something. Every sentence should do something. It should contribute something. You need to understand what an abstract is and what it does. At the moment, this looks like a large lump of text, and reading it may not automatically make you start thinking of what it's actually saying. But let's see what this text looks like when it's color-coded next to our frame. This makes things much clearer. Okay, the first sentence is a so what. The next couple describe the problem. Next one, what did you do to solve it? How well did it work? Gives you all of that. What does the work contribute? Now, if you have this framework in your mind, when you look at an abstract, it will give you a lot more information than just reading it word by word. If you know the frame on the left and abstracts follow the frame, it's much easier for you to read. And it's much easier for you to write. It's easier for you to read because you know pretty much where you need to look for particular things in the abstract that are related to what you're interested in. You may be interested in the background, you may be interested in the results. You can approach abstracts in a completely different way if you have a bit of a sense that the information that's coming actually fits in with very specific questions. Let's look at another example. Well, this one's about widgetology. In widgetology, it's long been understood that you have to glomp the widgets before you can squiffle them. At the end, we expect this new approach to dramatically reduce the cost of squiffled widgets. Again, this is a nonsensical example, but it shows you that if you have a structure, you follow the structure, it makes it pretty easy to see what's actually inside something. So again, taking this apart in terms of our color coding. So what? There is no known general method to determine when they've been sufficiently glomped. Well, clearly that's important for some reason. What's the problem? What did you do? How well did it work? And what else does this work contribute? Now, we're operating at several layers here. I've already said basic, highest level questions are what is it? How well does it fit in? And how good is it? You're starting to see these questions unravel a little bit into lower level questions. But keep in mind the higher level. We're going to be traveling down to a third level in further videos, and then we'll stop. But I'm just giving you a sense that information can be understood at various levels in terms of the writing in journals, which is writing at the highest level of engineering. So that gives you a way of handling the information depending on the audience. If you've got very little time, what is it? How good is it? How does it fit? Is the most useful knowledge that you can give to somebody. The briefest information. You may have 20 seconds to chat to an executive to tell them about a piece of work that you've been looking at. Don't blow it. You need to know how to think about information at different levels. Choose the right level based on the audience. The title of this video is about moves and steps, or more moves and steps in particular, because I've already shown you some moves with respect to the abstract, but the abstract isn't the only part of the paper. Each part of an academic engineering paper can be broken down in a similar way to which I've broken down the abstract. Let's talk about the sorts of things that you can expect to find in these sections. The basic structure for an academic paper is called IMRAD. Discussion and inclusion are often rolled together, and you'll notice the funnel. There's a funnel from the top in the introduction, passes through the methods and results section, and then funnels back out at the bottom. We're going to be encountering funnels quite a bit in this course, so you need to be prepared for that. Similar to the questions that I talked about, there are layers in which we generalize and become more specific as we travel through the layers. It's a very important concept to understand that words are written in funnels. You see this a little bit in the abstract, but you see it a lot in the introduction. And when I say you see it in the introduction, it occurs at the macro level and it occurs at the micro level. What we need to do is to train your eyes to pick up the levels so you know where you're operating, that you understand what something's referring to. The advantage of understanding this scheme is that if you understand how it works, it's much easier for you to write because you step through the levels of generalization. So let's have a look at some of the moves which fit within each of these sections. So let's start with the abstract. We've already talked through some of the moves. This is just a different way of representing it. 5 steps, again, background of research, answers the so what question, what the purpose is, what methods did you use, what results you got, and where to from here. It's a very common framework. Now you notice that each of these moves is coded with a letter and a number, and the steps actually have a name to them. Now the reason they're coded like that is because linguists have actually combed through many engineering papers and have pulled out the common elements in these papers. What we're going to be looking at in this video is some of the similarities and some of the differences between the different disciplines in engineering, because it's not all the same for every single engineering paper. And those of you who are taking this subject will be from different disciplines within engineering. You'll actually use different questions when you read and when you write engineering papers. So this will give you a little bit of some of the flavor of what those differences are. But the only way you can really appreciate those differences and internalize those differences is to write papers. It's hard work, but there's no other way. So let's move on to the steps in the introduction. So we're now going to move through all of those layers in the IMRAD picture. So the introduction. What you're doing in the introduction is you're establishing yourself in the field. This is what came before, this is what other people have done, and this is what I'm doing. You establish a territory and you occupy that territory. You talk about other people's work, you talk about limitations of their work, then you say what you're going to do and what your main steps are going to be in this paper. So it's all about presenting the background information, reviewing the related research, and presenting what your contribution is going to be. In some sense, it's an argument. You need to respectfully criticize other people to say their work did A, but it didn't do B. Or it didn't do A as well as it could have for these reasons. Or it did A and it could have been looking a little bit deeper to do D, or something like that. There's a number of different attack points, and we'll discuss those in later videos. But you'll start to get a sense of how you can do that and how you can understand other people's works and its limitations within a bigger picture. So they're the typical steps for an introduction. Let's now move on to the method. So this is about your experiment. What did you actually do? How did you collect data? What did you use to collect it? What is your source of data? And what is your method? Now this is slightly different in different sorts of engineering, because sometimes the method involves a design, it may involve simulation, there may be modeling, there may be a whole lot of components within the method, and sometimes you might want to break that out into separate sections depending on the size. So the IMRAD formula for papers, which is so common, doesn't get universally applied, but it provides a frame which sits on top of any paper that you can find at a certain level of generality. The basic moves are all there. The steps are defining terminologies. You need to do that in any paper. It's very important. What does your data look like? Where does it come from? What's your procedure? What are the background details? You're actually putting work there so that other people can replicate your results. You're sharing. You actually want to contribute something so that other people can take your work and do something useful with it. So make it as clear and as reproducible as possible. It's really important. Okay, having had a quick look at some of the steps involved in the method, let's move on to the results. Well, results, the simple moves are reporting and commenting. You restate the procedures very quickly, some of the research questions, general findings, specific findings, and then you get into interpretation. Look at the results with respect to previous studies and how do you actually evaluate those results. You need to think of a broader picture whenever you're putting a paper together. How does this piece of work fit into the bigger picture? And the way to do that is to discuss everything that you can find out about the bigger picture in terms of the most credible pieces of work that you can find. We'll discuss that in more detail in another video. So from results to discussion and conclusion, well, you're highlighting what the overall results are. What does it mean? What is their statistical power? What is their generality? What have you actually contributed? You need to state what the specific outcomes are. Now, there are outputs and there are outcomes of work, and both of those things can be measured in very different ways. I'm not going to talk much about measurement of those things during this course at all, just a little bit, because there's really a whole course in a lot of these details. So you need to understand that in some ways I'm really scratching the tip of an iceberg, but I'm trying to operate at a certain level of abstraction that allows you as engineers to take this and apply it within your own disciplines and apply it within your own workplaces. So you've got to put forward the strengths of your contribution. What are the implications? Where does it lead? Who might take this and do something valuable with it? You're actually sharing. Now, this whole notion of intellectual property doesn't come up with academic papers. Often academic papers, you can publish them, but you'll leave out some special little detail that would actually stop somebody from reproducing the work. So there are ways of protecting your intellectual property while contributing. So there's a certain balance to be had between businesses attempting to create a monopoly on technology and also being able to contribute in an academic sense to the academic literature that other people can take and build upon. There's a bit of a tension there, and engineers often have an agreement with other engineers that they'll just share data, share methods, share technology without worrying too much about intellectual property, contracts, all of that kind of thing. You can get away with some of that stuff to some extent, some of the time, and that's fine. But if you actually want to contribute in an academic sense, you need to actually have something that's valuable that you can share and that your company will allow.